All right, I guess we're going right into the next one. Accidentally started it up. So this one kind of gets into my whole light has mass. Because I think I'm gonna actually we'll save that for another one. I need to read through that one first because since I've written that, I've gotten a better understanding and I've changed my theory on it a bit. I've kind of talked about this, but I think we need to look at charge as empty and full. I think that that's maybe a better way to be looking at things. Because the full container has no room, and so other full containers, will like if they like if this thing's full, right? You can't pour more water into it. Like if you have a cup that's full, so you try and pour water into it, it looks like the water is repelled, but it's not really. It just nothing can go in there, so it basically bounces off, and so. The full container, it repels like that, and the empty container, can hold the liquid. So when you pour it in, it just stays in there, right? And you could say, oh, it's being attracted because it's going in, but that's not really. I mean, it's not really attraction. It's just this is empty, so it has room to hold stuff, right? And so the full container has no room, and if you try and pour nothing into nothing, then nothing happens. It's kind of like the same thing. You could say, oh, look, they're repelling. Like nothing is going in and nothing is staying. I don't know, but. If you were nothing, you're not going to go towards more nothing if you could go towards something. And so, that interaction is seen as like, oh, look, it's repelling, but it's really more like, well, there's nothing over there. Why would I go towards nothing? I want to go towards something, right? That's like you're walking, right, in the desert, and you see an oasis, right, to your left, and then you see just desert, nothing but desert for miles to your right. Would you describe your actions as being attracted to the oasis, or are you just going where there's water because you're really thirsty? You know what I'm saying? So, if you don't need water, right, then you'll be like, oh, I just, say you just were at the oasis, you just filled up. You're like, well, I just got water, I'm going to now go into the desert and go, continue on and go look for, stuff, I guess. I don't know. It's a desert. You got to get across it maybe. So you're like, I got to cross this desert. I just filled up. So now I'm going to go to the desert. You're not being repelled by the oasis, right? You're just full. You don't need the oasis anymore. So you're going to go where the oasis isn't. You know what I'm saying? Does that make sense? So, empty and full. And, the electron, and so I do have a more interesting theory about the charges and stuff of a nucleus in atoms, but I'm going to ignore that for now. And the attraction, comes from the flowing of energy from one place to another. And neutrons do not form atoms alone because I kind of want to. I'll say this tiny tidbit. I don't think neutrons are neutral. I think that they act neutral when when in a nucleus, but I don't think that they are inherently neutral, because if that was the case, then why do they bond to protons? And if they bond to protons, why don't they bond to other neutrons? We don't see neutron atoms. We see neutrons in atoms, but we don't see atoms made of neutrons. And why would that be? If they're neutral, and there's really, if they're neutral, there's not really a great reason for them to hang out with protons. Why not hang out with electrons? Why not hang out with other neutrons? Why not hang out with no one? Because you're a neutron. What is making you hang out with protons is basically what I'm trying to say. And so I don't think neutrons are actually neutral. I think that they have a very low charge, but I also want to say that I don't like the idea of charge. I think it's an idea of empty and full, right? And they don't need a lot of energy on average. They do pretty well on their own, but they could always use that little extra boost to get them to breaking even. And so that's why they hang out with protons, because protons are giving them the little bit that they need to keep themselves neutral. But without the proton, it's not neutral. But I also think that, just like we kind of look at charge as these set values, or it's +1 and -1, and and then you go into quarks and it's like 1/3 and 2/3, and I think that charge, well, it's not charge, it's empty and full, and that varies with time, right? Certain things are more or less full or empty depending on a given point in time, right? If you pour your water into your glass, right, and then you take a sip, now it's lowered its amount of water in it. Like, it's got less, we'll say water is equivalent to energy right now. So we'll say it's got less energy in it. So if it wants to get back to, a full glass, which is, like a balanced, it's, that's where it's at balance, then we got to add more water in. But it's not, it's not like immediately, it goes from neutral to completely empty, right? It slowly drains over time. You don't just, even if you chug your glass, it still takes a certain amount of time to empty it, right? So over that time, the amount of energy in the glass, the amount of water, reduces, right? And so its capability to hold more water, more energy, increases. And as its capability increases, it, wants more water. So, like I said, going back to the oasis, the thirstier and thirstier you get, the more desperate you are to find water. When you've just gotten, your fill, and you've got your reserves filled up, you're completely tapped out, you don't need to hang out at the oasis anymore, right? But when you're dying of thirst, you're, frantically looking for somewhere to get water. And I think that that's a pretty much what's going on inside of the nucleus. And And I think that when you look at things in that light, we can kind of see these interactions and see how they work. And this is a potentially long talk when I'm thinking about all the stuff that's in this. But what I'm trying to say is basically that atoms work on this energy full and energy low or empty like balance, and they're trying to be at an even state, right? Where they don't have excess or are in need. So like an electron shows up, and I think that this whole spin thing is more of a description of, is it like as a particle fills up, right? Let's just say any particle in general, as a particle fills up with energy, it eventually reaches a point where it's, full. So you got to think about it like this. Well, once it's full, it's using that energy. So it slowly is draining that over time. Again, going back to water here, imagine you drink a glass of water when you wake up in the morning. By the end of the day, you're going to want to drink another glass of water, because even if you didn't do a whole lot, your body is, using that water. You're perspirating, even if it's ever so slightly. Even if you're not really working out, you may not be sweating, but water is still evaporating. And every time you talk, when you breathe out, you're breathing out hot, humid air. And so you're losing liquid that way, right? You're losing water in that sense. If you, for some reason cried during the day, you're losing water that way. If you, went to the bathroom, you're losing water. So all of these ways, water is leaving your system. So you constantly have to get, a refill. And that is why, neutrons and electrons hang out by protons, because protons are basically this oasis where the water is being produced. Or like energy is being released in excess. So to think of that on a better term is, protons are like the fruit tree, right? And neutrons and electrons are there to eat the fruit. And the proton's just trying to get rid of its excess energy, and by doing this, it is pulling in, these other particles. These other particles are consuming this excess energy, and by consuming this excess energy, they're getting benefited. But what's happening is if we look at it from a plant perspective, plants produce fruit because animals eat the fruit, right? And there's seeds in the fruit, and then they, poop it out somewhere, and then that starts a new plant. And so it's beneficial on both ends. But in this case, the proton's not worried about spreading more of its own kind. It's focused on producing as much energy as possible. It doesn't need to reproduce because it doesn't need to die. So it's not worried about, spreading its offspring to keep itself producing, right? It just produces. That's what protons do. And so it's producing this energy, though, in order to attract in, neutrons and electrons, which electrons don't really have a whole lot of mass, but neutrons do, and they attract in these particles with mass. And what does that do? It increases the gravity, right? And on the atomic level, gravity is there. It's just so unfathomably small to us that it's almost, I don't even know if we could observe it if we tried. But I believe that it is there at the very tiniest particle. There is gravity, because gravity is not really necessarily a force, but more of a reaction to mass particles consuming space-time, and so I think I think that on some level, all particles are consuming like space-time, they all have some function of producing energy on their own, right? But they, like, some things are better at it than others. Like, their rate of production is is worse for some than others. And so, hold on, I'm gonna burn my bread too. I don't want to do that. All right. Since I can, I'll show you what I was talking about. My bread here. I think it cooked long enough, but like it kind of just like tore on the side. I tried to score it on the top, but I guess it didn't work out so well. You can see my little square there. Maybe you can't. Anyway. Where was I? Basically, particles are, taking, like, they can produce some of their own energy, but they can't do it forever, right? So they have this rate, they have like, there's, that's too deep for right now. I'm going to ignore that. I'm going to move on from this. It's a distraction. It's not relevant at the current time. Anyway, they're attracted to the proton because the proton is producing excess energy that they can, consume to keep themselves at balance. And basically you're saying, okay, well, where's all that energy going? Maybe that's what you're saying, because obviously it makes sense to us. Like, we sweat and things. That's where the water is going for us. But where's the energy going for the particle? Well, I don't know if this is an established thing, but I mean, all the particles are radiating. They're radiating energy. Light is like is a byproduct. It's a waste product almost. It's not it's not necessarily something that the particles that release it want. They're releasing it as like a byproduct to interact and move around and just exist, I guess. And so as a particle exists, it is radiating energy. And, if you don't think that is right, then explain to me why you glow up in an infrared light, right? Why do you give off body heat? Where's that body heat coming from if not the atoms that make you up? Anyway, what happens is that, so they attract, right? They come over to the proton, and this builds mass. And as the mass increases, the effect of gravity increases. And so more energy flows out of the proton because the proton's energy production is based off of pretty much the flow rate of energy through it. And as you increase the mass, you're increasing the flow rate. So as that increases, the proton's now producing more energy, and then it allows for the proton to take on more electrons or take on more neutrons and kind of build up its mass, but it can only produce so much, right? So at a certain point, this proton is producing, right? But it can't handle, one proton cannot handle dealing with 50 neutrons, right? because even though the neutrons are neutral, right? I don't think they're actually neutral, as I established. They're very slightly negatively charged, but even though it's just a tiny amount of this negative charge, for simplicity, I'm just going to keep it like that for understanding purposes. But at some point, it's too much, and they start to take more energy than the proton can produce, right? And so, that's when other protons enter in, and they can rebalance it by producing this, and it benefits them because if they join the party, now they're getting more energy flow, right? And producing more energy out, which is attracting in more mass. And so particles are slow, would build up, but they need large amounts of energy to do that, right? And so in order to have that excess energy to bring on basically another particle, that energy has to be introduced, and when that energy is available, it's possible to take on these new recruits, basically. One way I could kind of think of this is if you're running a business, right, and you're just breaking even, you're not going to hire another staff member because you can't afford to pay them right now because you're just breaking even, right? But say you had really great sales the past 2 weeks, 3 weeks, maybe a better thing is the past 4 months you've had really great sales and you can't quite keep up with the demand, so you're okay, well, I can't keep up with the demand, but I've got a lot of money saved up from all these great sales. I could keep these sales going and keep up with the demand if I take on just another hire, right? So that's basically what's going on inside of the the nucleus. Is these protons are they can't afford to take on these new hires, as I'll call them, unless extra income is introduced. But once they've hired them, then they can maintain them because hiring them has now allowed them to increase the amount of money that they make as a business. If that if that makes sense. I feel like I'm using so many different analogies, but it just goes to show how many parallels there are between this, our world, right? And how we interact, and the particle world. It's not just up here, and it's not just down there. It's everything, right? So these relations exist for everything. Anyway, so that is why, long story short, I don't know, I kind of got really off track and went all over the place, I think. But long story short, that's why I don't think that we should use positive and negative charge, and we should use, full and empty, or excess and lack, or something along those lines, instead, because I think that it leads to behaviors that align with what we see, and also potentially describe things better and allow us to understand things. And I don't need any complex math to do it. I just observe how things work in our world, and then I'm looking at how this is working, and I'm saying, well, that doesn't seem quite right, because my biggest thing is where are if charges are such an innate fundamental force of the universe, where are they at our scale? We don't experience, these attractive forces ourselves. Not truly. Any attractive forces we feel, it's on the atomic level, and we're being impacted by what's happening on the atomic level. When I'm eating food, right? We don't say that my mouth is, negative and my butt is positive because, food goes in my mouth but out my butt, right? That doesn't make sense. But that's the same. It's the same thing. Energy is going in, and then coming out. And if you try and do it the other way, you don't get anything for it. It doesn't work the other way, right? So, what I'm trying to say is it doesn't make sense to use that description because it doesn't. I don't see where you would use that term to describe basically the same exact thing on, our level. So, now I think I'm done. Now I think I've said my piece. So, peace out.